This conference will now be recorded.
Okay. Hey everyone, happy Friday and everything. Um, Three things. I said two and then I lied. One is we have to talk about the OCP Global Summit coming up. Um, in terms of there are about three panel sessions we have. My plan is you probably got a bunch of email about them. What I'm going to do is next week we'll send out some email organizing all the panel sessions. So for each panel session, hopefully we'll have a preliminary meeting sometime in the next 2 weeks. So I will send out an email introducing the panel moderator to all the participants. And I think Cliff will take care of Tom and the last panel. And between that, we hopefully there is no expectation on necessarily having slides for a panel. You're welcome to. And between that, we should be reasonably organized. And on the Experience Center, we had an organization meeting a couple of weeks ago. It's looking really good. And hopefully we continue to make good progress on that over the next 3 weeks. Okay, Cliff, anything you want to
Uh,
add?
Bobby, can I ask
Bob,
you a question on that one very quick one? Like is the panel I'm doing under your, when you say
Cliff,
organized, I'm sorry.
I can't. Tawfiq, it's just me or everybody else. You're breaking up.
yeah, Taufik's
Oh,
breaking.
is it better now?
Not
It's
a
pretty
whole
bad
lot.
here in North Carolina.
Oh, so can you hear me?
Not
No.
really, Tawfiq.
Okay, I'll try later. Thanks.
Maybe you can type your question in if you wouldn't mind. Go ahead, Cliff.
Yeah, Poppy, I was just going to say perhaps a few words on the workshop that we just had at Lawrence Berkeley Lab. Might be good for everyone
Oh, no,
to.
I'm so that was going to be my second thing after this.
Sorry, I
So
missed that.
no worries. Once we get this out of the way. Anything else you want to say on the global summit?
Uh, uh, were you going to talk a little bit about where we are with the experience centers and organizing it?
We had a session about it 2 weeks ago. The entire meeting was about that. So I think we're okay.
Okay, great. There's and no feedback since then.
Yeah, I forwarded the. David, you had a question?
yeah, I have a quick question about the panels. So the notification about the panels and the presentation submission, the deadline for that is the 25th, which is end of next week.
Right.
So if we have meetings in the next 2 weeks, would we miss the deadline? Can we submit slides after the deadline?
Let's see. Hopefully, we get a meeting. If we don't, yeah, we'll ask for a little bit of slack in the deadline, because your panel sessions are going to be only a pair of slides each. They're not going to be a lot. Um, each speaker is probably we're better off with 1 or 2 slides per speaker, so we should be okay. It's not a full talk.
Bobby, can you hear me now?
No, Tawfiq, I apologize, but no. Okay. As Cliff said, we had a pretty successful OCP, DOE OCP workshop, well attended, and the agenda was really well received. I was kind of surprised by how positively the agenda was received. There was actually a direct report out, and John Schaff has actually volunteered to do a brief presentation on this at next week's meeting. Um, so Um, Cliff, what I was thinking was that we would do this next week when he's ready to come with like a full debrief, as it were.
Okay, great.
So we had a bunch of people online. I'm assuming a bunch of people here who attended, who attended either remotely or in there in person. Uh, that so it was a really good event. It was 2 days. The second day was a lot of brainstorming and some sort of very government focused brainstorming. And we will give you a report out next week. Okay.
Poppy, maybe it's just good to talk a little bit about what we expect from the outcome, just so people know what might come from the workshop, like next steps and things.
Right. So For sure. So our day two was devoted to figuring out three topic areas and how to make progress on them in terms of what were the opportunities, what were the challenges, and what are the gaps. And I think the three topic areas, going by memory, one was applications, the second was simulation, and the third was software, I think.
Yeah,
Um,
software and how to build an ecosystem, how to stimulate an ecosystem together.
Software and ecosystem development. Those are the three topics, and really the discussion was sort of very government centric, and government's needs are very different from industry needs in some sense in terms of their timeline and what their constraints are. Um, and what was so the idea is that over the next quarter we develop a white paper. We will have a follow-up meeting at the global summit. Um, and then we'll have second. We have a panel on this topic on chiplets for high performance at supercomputing in November, and then on top of that, the idea is to do a report out at the chiplet summit in January or February, whenever that is. That's the rough plan. Did I capture that, Cliff?
Yeah, and the only, I guess I'd like to share couple of my perspectives where initially I thought the OCP might be able to help. So from the first readout area around, what are the applications specifically around HPC that there might be specialized chiplets that would be needed that could be spec'd by the LBL and others from the government, and I'm hoping that some of those specifications would actually become contributions to the OCP, so they'd be out in the open that people could start to think and develop around them. I also am hoping that some of the discussion around building an ecosystem or economy that comes out from the third area that people talked about might ultimately lead to some programs where we, the OCP, can help create a coalition of some of the companies that are in our community to help solve that problem. So, very early thoughts on how the OCP would continue to work with the government agencies to push forward within the community. I don't know if we mentioned it, Boppy. Does everyone know that we were successful in having Lawrence Berkeley Lab become an OCP member? We just signed the paperwork the last week or so, and so that means that if they do a white paper, they can then be a proper contributor on it within the OCP, which is something they wanted for their people.
Yes. So the Department of Energy, the Berkeley Labs is now a member, which is like a big thing. Other labs there's interest in other labs and also becoming members. One particular outcome is there is a researcher in, I think it's Oak Ridge, who's very interested in software development, and she'd like to present at some point in the next few weeks on kicking off a software planning effort. And I think Vishwa is in the same bucket. So hopefully we get something going on the software side over the next quarter or so.
Yeah, and Boppy, also, I had someone reach out to me that is doing work in simulation and was, I think, also going to approach us to present to the group, looking at how we can use simulation to predict how a SIP might perform based upon the chiplets that are going to be assembled into it. So rather than obviously waiting until it's built and then it doesn't work. Um, so there might be some modeling elements there that we might be able to build some tools for the community.
Yep. And one of our strengths as a group, I think we're small but mighty is the easy way to put it. We have, it's safe to say we have a pretty good collection of startups, and that is something that is of interest to more than one government agency. I will be meeting NIST and some portions of the NIST that deal with the CHIPS Act to present our sort of do a presentation on our activity in the next couple of weeks. So hopefully we get a chance in terms of our interest in working on the CHIPS Act. We get a chance as a group to sort of share our wares and contribute to the activity in chips and chiplets and packaging.
Yes, I heard the same thing, Boppy, that when I had a chance to chat with Hal, that there would be interest in potentially partnering with OCP because they saw us as a place that could bring together public and private sector elements into a coalition. And as you said, we do have a lot of the startups in our community, so we would be one of the places that could uniquely bring that potentially.
Exactly. Okay.
Boppy, I noticed Alan and DJ are on the call. Since they were strong participants, I wonder if either of them wanted to add anything.
So, Cliff, I'm assuming you're talking about the DOE workshop, right?
Correct.
I think both you and Bapi covered most of the important elements, in my opinion. And I think I'll just echo the point which is made earlier that OCP, I think, can play a very important role, especially on the promotion of chiplet ecosystem. So even in terms of what we are doing at OCP Summit, Bapi talked about the Experience Center and bringing all of that visibility back into DOE is important. The only one comment which I will make based on my observation is that business model for applications into DOE will look very different from the commercial side. Most of these applications on the DOE side seem to be very low volume first and very different use cases second, compared to commercial side, which is driving the chiplet world. Reconciling these two worlds together with a common technology application, I think that is going to be a challenge. And I don't think we addressed any of that in the workshop because this was the first workshop. But there should be some effort done, I guess, more on the DOE side to distinguish their use cases, which are very different from commercial use cases. And I didn't get a good sense of their use cases. I tried to ask those questions, but the answers were not very clear to me. So I think this is one area where probably more work needs to be done to make sure that commercial companies are engaged in serving these use cases on the DOE side. So those are my quick comments.
Yeah, this is Alan from my side. I concur in terms of what Bapi and Cliff have said, and to a certain extent, DJ as well. I guess for me, what resonated with me is the government's desire and will to actually build an ecosystem outside of the big guys, and to drive their specific needs, but also with the big guys, obviously, as well. And it looks like OCP is really uniquely placed. That's why I've always enjoyed OCP. It's uniquely placed to bring a lot of really smart small players together under this open roof. And so I really felt the government agencies clicking on this side of the equation as a result of the 2-day workshop. Now, obviously, it's a very long process, so don't hold your breath for sure on this. But it looks like we do have a unique opportunity here. To Cliff's point, OCP can play a big role in this. What OCP looks like today, or what it needs to look like to play that role, I think is a question that we'll need to stew on. The only other thing from my experience is of trying to get something going with the government agencies from the OCP HPC sub-project perspective is that they love the idea of the open collaboration in lots of small companies working together to bring open industry standards together. The problem is they're used to having one throat to choke, as they'd like to say, and so it's a challenge for them of how do they solicit these contracts where maybe they've got to put small contracts on everybody, on many companies to bring an ecosystem together. And so, OCP is not really geared up to be the one throat to choke. And I was, because IBM tend to be very open in terms when they push stuff out. I did attempt to get them as a possible coordinator towards that and a member. We may be able to do that with them, or another large company. So I guess that's my biggest view of getting traction on this is how does the government work out a way to actually fund this and monitor it in terms of making sure things are delivered and money is spent well.
All right. Thank you. Let's see. Oh, and JP, sorry, that was 2 more minutes. I've got great news. Quinn and Shahab, it looks like we've got a site for our technical workshop.
Yeah, do you want me to present something about it? Can say some feedback?
Sure. Actually, then in that case, yes.
One page slide then.
Okay. And Quinn comes bearing gifts, right, Quinn?
Yes.
Do you see this page?
Yep.
Yeah, I think thanks, Quinn. I think Quinn managed to get basically the venue at CMU at Silicon Valley. Our target is Monday, October 16, a day before OCP Summit. Still, we don't know it's going to be a half a day or full day. It depends on number of participants. We will decide. For now, we decided to be in person. We're expecting 10-15 presentation, each one 20 minutes, and a networking at the end. We may actually have a panel or keynote at the beginning and end to make the presentation, the workshop more organized. As soon as we finalize this thing, we have to send invitation letter out, and I'm counting on the help from DJ Anu, John Schaff, and Cliff and others, basically to basically send the invitation letter to all the participants. And we're gonna send basically the guideline that we have for presentation and templates. So far, thanks for CMU to be part of it as a providing the venue, and I'm gonna reach out to IEEE if I can actually seek any sponsorship list. These are basically the list of possible participants from past whatever we had, and some of them are new basically to our list. I'm not sure if we get any attraction from OpenHPI or Intel AIB, but I already include them. Anything else, Bobby, that I missed? My plan is actually we should finalize our plan by September 1st and send out the invitation letter before September 1st. This gives basically us 6 weeks for advertisement, and we should close the program on September 16th. Then we know the final program of the workshop.
So if we want to close by 16th, then we probably have to send it by next week, not the first. 15 days is likely not enough time for. Usually people need about 4 weeks. This is awesome. So having a when you put a plan out there, it's easy to take pot shots at it. So thank you. So we should send out in August 23rd, and then we give them about 3 to 4 weeks to respond, and we should be good. August 25th, 1 week from today. Excuse me.
So
Quinn,
Bobby,
does that
then
meet with your approval? Sorry, Cliff, go ahead.
I was going to say then we'll probably need some sort of internal call to organize this
Yes.
early next week. And the good thing is we can cookie cutter a lot of the work I think we did for organizing the DOE workshop. Most of the
Yep.
infrastructure is still there.
Great. Just one question. Sorry, Quinn, I should ask you offline. Do you know what's the size of the venue? How many people we can accommodate?
So the facility I've reserved can handle 75 people.
Okay.
That would be a little tight. It'd be better. I mean, at 60 people is comfortable. At 75, we're using every seat.
Okay, then we set the in-person limit to 60. If we get more than that, we will think about actually to make it online available too.
Okay,
But
so then,
I think our target is only in person.
okay, so the only thing about making it online is we have to make sure the AV equipment supports that easily in the venue.
Of course.
Yeah, so that it's our auditorium set up to do online. It's got all the equipment. I think to some degree, if we can do in person, I think it may be a more intimate and productive, but we'll do what we need to do. But we have the capability of doing either.
Great. Boppy, any more feedback? DJ, Cliff, Anil? Sorry, I'm calling people who provided feedback at the beginning.
Looks good to
So,
me.
very quickly, I think, Shahab, you are going to share an Excel sheet with email addresses, right, for us
Correct.
to
Yeah.
use? Okay,
Uh,
okay.
yes. Some of them I do have access. Some of them we have to
Yeah, I
use.
think if you could share, I might have, but if you could share it in a sheet, then we'll just copy paste rather
I,
than,
I will
you know,
create a Google Sheet and share it. Then everybody can have access to
yeah. Thank you so much, Shahab.
it. Good.
Hey, Michael from Samsung. We're hoping to see one or two files from Samsung at this event as well. So hopefully we're giving you enough notice to participate.
Okay, yeah. Let me check with the founder side, Okay.
Oh, thank you.
Thank you.
Thank you.
Okay, so I think this is if this works, this is going to be a template for some other workshops. Like David, we should consider one on CDXML, sort of a really detailed technical workshop rather than something at a high level on how awesome chiplets are.
Okay.
All right. Any other questions, thoughts? Quinn, Shahab, thank you. And then we're going to do the panel as well, so we can work out the agenda hopefully over the next 2 weeks or so. And anybody else, Zeng, if you guys want to come with either Bora's lab or your lab or somebody else's, if you guys want to present, that'll be perfect as well. You're welcome to.
Currently, we don't have some solid work to publish, but also I have an update that I found that if we can ignore the topology inside each chiplet, we can do some bottom-up synthesis. You might be interested.
Okay. So then that you're definitely welcome to present that here. But you're sort of our rep into UC. So for the other groups, if you can share this idea of a workshop and say if they have a file they want to present, we'd love to hear from them at this event.
Okay.
Thank you.
Thank you.
And Majid obviously can do as well. Anybody with a file, where you're welcome to participate in this.
Sure, thanks.
And Kash, of course. Okay. Then JP, I'm back to you.
Yeah, hi Bobby.
There you go.
Can I take it over?
I think so.
Okay, thank you. So we have. Good morning, everyone. So hope you can see my screen now. Let me put this presentation mode. Yeah, so I want to update on the BOW interop platform. So we have been working on this for quite some time. I want to give an update where we are and what the next steps are. So the first is first I'll go through a brief overview of what the platform is about, what we're developing, and then I'll go into the ingredients of the platform, package, PCB, what the budgets are, and the next steps. Right. So the first is why are we doing this effort? Right. As you know, the BOW 1.05 has been adopted in several commercial implementations, and many of these implementations are vertically integrated, meaning the chiplets come from within the same company or the same IP. And for the larger adoption, the next step, what we expect to see is actually chiplets from multiple companies, multiple implementations will connect together to form larger products. And many of the participants actually expressed interest in that. And and they want to have some confidence in doing so, right? And that's where the interoperability comes in. And this is the why we want to establish the interoperability, show the standard, what's being developed, independently implemented by multiple companies, can interoperate each other. And right, so that's the essential goal of this work. And this interoperability remains to be demonstrated, right? And as a community effort with the OC in the spirit of OCP, what do you say? We are developing this interoperability platform as an open source effort, and this is in progress. And which is what I'm going to review where we are, right? So this is a kind of broad overview of where we are. The first step is really that the 5 test chiplets, right? So we have 2 companies contributing to the 5 test chiplets, BOW 1.0 spec running at 16 gigabits, Blue Cheetah Analog and D Matrix. And they have proven their test chip. They demonstrated the test chip by itself, and they've been proven, right? So that we take these chiplets and put them in a package so that these 2 chips, the Blue Cheetah and D Matrix chips, can talk to each other, and we can test the interoperability. Right. So this package development has been completed with we are tape out ready. And this package development is contributed by several people. First of all, Google actually did excellent work on demonstrating the feasibility. The Blue Cheetah and D Matrix have different bump patterns, and we had some issues whether we can interoperate, connect them, wire them together. And Google came out with the interesting idea how we can wire them together and still run at 16 gigabits. And then the layout was done by TSOL, and SI signal integrity power integrity analysis has been done by IIT Bombay. So the package itself is tape out ready, and the fab, the ATNS has kindly agreed to fabricate this package. The ATNS is a a leading fab based in Austria, and assembly will be done by JSET. Right, so that's on the interoperability package, and the next is actually the bring up PCB. The bring up PCB, we have, as we are talking, getting ideas from different people. One of the things we thought that got ideas was we need anyway interoperable bring up PCB for interoperable package. This is a custom package. Therefore we need a custom PCB for this. But why not do a universal bring up board? So anybody who is doing a test chip or anybody doing some sort of this kind of work, chiplets work, would need a bring up PCB, right? And this has been like recurrent in the industry, be it for the BOW, be it for any IO standard, be it for any test chip for that matter. And we need something, bring up board. Why not make it universal? I'll explain the architecture. And the LBI Lawrence Berkeley Lab actually is very much interested in this approach, and they actually a strong proponent of this. And so currently where we are, so we are in the defining the platform definition for the PCB. The PCB design will be done by Lawrence Berkeley Labs and NXP, and right. And the other part is the bring up software and test software, right? So that is actually will be largely contributed by dmatrix and Blue Cheetah, but we also need a platform. We want to make this an open source platform so anybody can use as a generic bring up board. So we would need resources in the software side to make it as a very generic platform. right? And the interoperability demo and interoperability will be hosted in the LBL lab facilities, Lawrence Berkeley Lab facilities. Okay, I'll before you head further, are there any questions? I'll pass quickly and then check if you have any questions. Okay, so that's good. So let's move on. So next is
Actually,
actually I want.
just one. Sorry, just one question.
Sure, yeah.
So, as a sort of a universal bring up platform,
Hmm.
are you looking at that just literally from a bring up perspective, or are you looking at from actually that platform could be used in a wider context as a complete, as part of a bigger system? What's the scope of the universal platform, I guess? Hello, can you hear me?
Yeah, I can hear you. Maybe we lost JP. Yep, looks like we lost JP. He's back.
Yeah. So Alan, do you hear us now?
Yes, I do.
Yeah, Alan, if I understand your question right, you are asking whether this bring up platform is limited to the test chip bring up or something more than that. Is that what your question is?
Yeah, yes. Whether it could actually end up being a usable device, let's say. So, obviously there's a bridge. What you're doing at the moment, between D Matrix and Blue Cheetah, is, like you say, it's a nice small test platform. But it would be good if every chiplet designer could use a common test platform. So I understand the perspective, but I was
Mm.
just wondering about the scope, whether the scope would go to a sense of being able to plug this into a bigger system and actually use it as a chip in a bigger system. So
Mm.
that was my. I'm assuming
Okay,
not,
I
because
see.
that brings more complications in. But
Yeah, it's not something you can deploy readily in a product because the requirements for bring up versus the product deployments are different. But I'll
right,
go through architecture. Maybe you can give more feedback and see if we can accommodate that.
okay,
Yeah,
thanks.
yeah. So as you said, it's not limited to BOW or anything. It can be used for UCIe. It can be used
Yeah,
for, let's say, DDR, any chiplet for that. I mean, any chip for that matter.
right.
Um, okay, so let's move further. So the next is actually the interop package, what it looks like. Some of you may have seen this picture. So the interop package consists is a 40 by 40 millimeter organic substrate. It consists of five test structures connecting D matrix and blue cheetah dies in various configurations, and will use a very low loss dielectric GL102 and have a length ranging from 5 millimeter to 20 millimeters. Right, all in all, have a 10 dies, and this layout has been validated and completed, and we are tape out ready. Right. So this to give a snapshot of the test has been done, like the signal integrity and power integrity. This slide shows the signal integrity, and you can see here a very clean eye meeting that the BOW 1.0 high mass specifications by a pretty good margin. So we are very confident this will help us demonstrate the interoperability, and the margins look good, very healthy. Right. So the other thing was we spent a lot of time in power integrity. One of the challenges of chiplets is really they operate at low voltage, especially BOW interfaces. The supply voltage is zero point 0.5 volts for the VDD and this was become a challenge to close the power integrity specifications, and we did complete the meet the specs, and the graph here shows that on the x-axis different decoupling capacitor on the AND package and what the supply noises, and we are able to meet the specifications for the given die. And so this work is is very well done by Ishan from IIT Bombay, And we are publishing this in a paper, item paper, and also we'll soon have an OCP white paper as well, so that the community can benefit what challenges we faced and how did we address them. And we'll also make this layout and all the design files available for anyone who's interested in using it as a starting point, or for their own analysis. Right. So the next is actually I will talk briefly about the bring up PCB as well. I mentioned it's going to be an universal PCB, bring up PCB. And so I'll first talk about the few features and then show what the platforms looks like. First of all, it's very modular and reusable platform. So currently, everybody does this kind of bring up PCB for every company in the semiconductor space where will do a number of these boards. And the challenge is every time you have a new chip, you start designing a completely altogether the bring up PCB. So what we want to break that up do is we want to simplify it, and only the duty portion of it you will redesign, and rest of the platform infrastructure like power supply, control, and clocking, reset, all this is kind of reusable across projects. Only the duty portion of it will be actually is modular, and that's something you need to design for a given chip, right? And it'll have a very robust mechanical design for tabletop operation, because this lab will be using it quite often, and needs to be rugged, and it'll have a very robust mechanical design. And it'll have the duty board is separated from the main board, so that you can change it as you need with the chips. And so it will support packages. We think it's supporting a package of the 100 by 100 millimeter. So it's pretty large for a test chip, but still it gives many options. If somebody were to do it some large package, still we can accommodate it. And it'll be socketed and it'll have a thermal head capabilities. The mechanical design will accommodate it. And it'll have FPGA and CPU control boards, right? And it'll have a remote bring up and test execution capabilities. Right, it's based on Xilinx Arctic 7. That FPGA design actually comes from LBL. They have already developed some kind of internal designs, number of internal designs, and we are leveraging that one of their FPGA designs and the boards, right? And we'll have a Raspberry Pi 4 for test execution. It simplifies the software development, and it's a very well-known platform and also powerful. And it'll have programmable power supplies, clocks, and resets, and it'll have a flexible displays for debugs and status monitoring. Right. So this is a kind of overview of what the platform architecture is. So it's on the left side. What you see is a Raspberry Pi connected to an Ethernet or USB for the the home and the platform it allows the platform to be logged in remotely, and then it'll connect to a Arctic 7 FPGA. Arctic 7 FPGA is very fairly capable FPGA with flexible IOs, and can implement a number of this IO protocols like SPI, JTAG, I2C or I3C, or even your your custom logic, right? And so it'll connect to it'll drive the DUT. So, and the voltage levels for this can be programmable, and it can also do PCI Gen 2 for control, or you can have a number of LVDS signaling as well, which is configurable. And then the DUT socket itself is very passive. So what we have is only a kind of DUT plus some few LEDs and connectors and right, and headers. So we want to keep the DUT design as simple as possible, so that all the intelligence is on the baseboard, so you can control it. And the other thing is actually, I mean, then I'll show you that what that board looks like from a high level. This is the concept floor plan, what it looks like. So the board itself is about 18 inches by 12 inches, fairly a bigger board, but gives a lot more flexibility. So, so this is what you see is the motherboard is kind of backplane where the cards plug in. The baseboard itself will only use as a conduit for wiring, and the rest of them you can plug in and plug out as you need for your project. Right, so you'll have a pluggable power modules. So if you need higher power modules in future, you should be able to change it. Same way, if you need, let's say, we'll start with Arctic 7, but you need a larger FPGA, something you can accommodate that. And then same with duty as well. So they'll all be packaged in a 18 by 12 inch form factors for lab tabletop operation. So this kind of flexible architecture will allow you to, we believe, will allow you to actually evaluate or test or bring up UCAE, BOW, or let's say a DDR, HBM, any kind of test chip for this matter. So it should largely simplify the efforts from companies that are doing themselves this test chip bring up boards, right? And we want to make this an open source, including software, hardware, so anybody can. And then we have a larger adoption, and we also like to get more inputs from the team who are possible users. If you're doing a kind of test chip bring up board like this, we like to have your inputs and make this as a kind of an open platform, so the community can benefit. Okay, and that brings me to the what is involved in making this all happen, right? So this is actually the budget part of it. Some portion of this we already completed, some portion is still to be done, and that's what I'll review it now. So what do you see here? What the item on the left, and then we have identify the cost. What will be the minimum cost, and what can be the maximum cost depending on the vendors we talk to. So first, we actually the first three items, the package feasibility and the package layout and SIP analysis have been completed. Some of them are in kind, and thanks to Meta, Google, and IIT Bombay and TESOL, we could complete it. And this layout and the analysis files and simulation test benches are available for anyone who wants to use it. This will be a good starting point for anybody who wants to actually involved in this. And the second is actually the part is actually substrate fabrication. This is something that the vendors don't have control. They are to pay their in turn the vendors. So there is some cost involved in fabrication, but like mass cost. And and then there's a substrate assembly cost, and then that requires some test jigs for assembly, so that involves some cost, and the duty design and FPGA board design. We are leveraging lots, so the cost has become more competitive since we are leveraging from the LBL internal designs. And then we also have the base board and duty board development and design. Right. So on the left side, what do you see? The minimum we expect to see somewhere around 150K for all this, and then the max what we see is actually about 300K. Right, it's somewhere between. The actual cost would be somewhere in between to develop this platform. And once we develop, we plan to have about 10 boards to start. And if we get everything right in the first revision, we get 20 boards. If not, we'll have 10 boards for 10 boards. So, and then once this becomes like a reference design, anybody can take this design, the spread of OCP, and manufacture it, make it available. We expect to see the larger adoption, at least for the bring up board. And since this being a common requirement, recurrent theme in the industry. Right. So that's actually on the platform budget. So Bobby, do you want to add anything to this before I go to the next steps?
I'm glad you asked me because I'm going to check out in a minute and a half. Um, I think that the specific concrete ask is we're going to have to raise somewhere between 150 and 300K. We're hoping closer to far closer to 150 than to 300. So far, it's been a fantastic community effort. You can see that we've got contributions from Google, Meta, IIT Bombay, TESOL, and now we've got projected contributions in kind from AT&S, JSET, LBL, and so this is a good community effort, exactly what the spirit of the OCP is. And we also expect that this should be useful to everybody building chiplets, not just people verifying Bo chiplets, as it were. Um, we would like to ultimately go to the OCP board and go to the hyperscalers and say, hey, please give us some money to support this. But that case becomes much stronger if we can also get people who are using this to contribute to its development in a smaller amount. That's a much easier justification inside a hyperscaler to say it's a community effort, and they can support it as well.
This is a great example where the government involvement could make things move a lot more smoothly.
100%. And I would really like to get some support from us as well. Um, and and then David just sent an email. This data is accessible. One of the interesting things is we know that people are using this data even in their own private development, which is exactly what we want. And we're happy to have more people use it. So this is creating a rich data repository that's available today for anyone. So we would like to please raise this money about 150K. And we're presenting here. JP has been kind enough to present here, has been a tireless champion to go help us raise this money.
Okay,
So
thank you.
everybody from a company here, if you could please consider this, I will be reaching out to you individually as well. If you could please consider this, it'd be really, really useful to the community. Thanks, JP.
Hey, Bhakti, I wonder if this is worth doing some sort of targeted campaign. Um, we do this often when we're looking for sponsorships for particular reasons within the OCP, and we do kind of a mailing to a wider mailing to the community. Maybe this is something worth considering. Just an idea.
For sure. For sure, and that we'd like to spark that conversation here. I'm going to hop off. DJ, somebody was trying to say something. I thought it was DJ, but maybe not.
Okay. Yeah, Cliff, I think that's your plan sounds good. Maybe we'll talk to this more. Definitely, I think it'll be a larger useful effort for anyone who working on test chip bring up. So a larger effort would be helpful. Okay, and so that brings me to the next steps. The next steps are raise funds and and fabricate the substrate and assemble the substrate with the test chip dies we have, and then bring a PCB design which is in definition, and that needs design needs to be completed, and LBL agree to do large part of it, and then we'll fabricate those. And then we're targeting interop demo by March next year, coinciding with the OCP Regional Summit. Okay, so that brings to the conclusion. So I don't know if Bobby is still there, but yeah, any questions or any thoughts how we can get this further?
Quick question, JP. Is there a requirement and high-level document other than PowerPoint?
On the interop platform, I mean,
Yes.
bring a PCB in particular.
Yeah, interop platform and everything you presented.
We have something in a high level in the works, but I can get you one actually. Yeah. So you want to kind of see a kind of Word document,
Yeah,
right?
something that people can go to, and it's not just PowerPoint and
Sure, definitely. Yeah. So
yeah,
we get that going. We
yeah.
already working on it, but we can accelerate it and provide you one. So
Oh,
a
okay, yeah,
cohesive document.
yeah. Because then it allows us to circulate inside company.
Sure, absolutely. May I know who is speaking?
It's Majid, can do.
Oh, hi, Majid. Okay, sure.
Yeah,
Yeah,
yeah, yeah,
definitely. Yeah.
yeah. Thanks.
Yeah. Thank you for the input. Yeah.
Yeah, yeah.
Any other comments, feedback?
Yeah, I know that UCIe is doing this golden chip concept, right? Where they're
Right.
testing
Golden
the
die.
golden
Yeah.
chip.
Yeah.
Have you looked at incorporating that so that it can be a more um, you know, wider for some wider adoption?
Sure, yeah, absolutely. I mean, the UCE is doing the golden die concept, right? They are, I think there's in a definition, and and but they would need a platform like this to anyway to bring up that, right? So this is there'll be a custom package design for it, and then they will have to do a PCB design as well. So it can certainly accommodate the proposal here would certainly accommodate whatever UCAE is doing for the universe, the golden die, right? It'll be a perfect fit for it, right? The package design would be different because the die design is different from BOW die designs. But the interrupt package, the duty board concept that we have will be leveraged and certainly can be used.
Yeah, so if you look at what they've written, I don't know how real it is at the moment.
Mm,
They're going to be wanting they're going to build something that will allow you to test the standard, the specifics, right? So
mm.
it seemed like when I was looking at what you guys were doing, you're really just connecting the D matrix chip to the blue cheetah chip, but there's not much in those chips, right? So you're just trying to see the signal integrity across that link, right? But there's not really validating interop.
Um, the
You know
interop
what I'm
is a
saying?
high
You're just
level.
saying, you're just checking, can I connect this to this? And then, I mean, at a very basic level, right? It's not really checking compliance of, does it meet the standard? I guess that's that. Maybe I didn't word it right, but yeah.
Yeah, no, I'll put this way actually. The BOLE consists of multiple layers, right? So the first layer is actually the file layer, and the second link layer, and then we have other layers above that. So what we are targeting here is the file layer interoperability, right? So it does not address the link layer. The link layer can be done in future, but as a first step is only addresses the file level interoperability. And still the chips are done in two different complete implementations, two different technology nodes, and the voltage and the frequency and all and the basic initialization protocol, all they need to handshake with each other, and that's what this interoperable test will test first, right? They also have a lot of state machines to bring them up, for the link. So there are several nuances involved within the file, and that's what this will address. This interoperable test will address. Kash, does that answer the question?
Yeah, no, I get it. It's just for the file layer test, I guess, right?
Correct.
So,
Exactly.
right.
Exactly.
Okay. So if you're going to do a link layer test, you would need something more complicated, right? You can't just have.
Correct. You need a die for it, right? So you need I mean, I don't know if BOW we agreed on a link layer full specifications, but if you have a die available, definitely we can put this in. What the UCE, what they're doing is they have a full die, the golden die. Let's say one of the die will be a golden die, the other die will be a duty die. Anybody can put this die on the package, right, to test this interoperability. So it's a similar in concept, right? But so what would change is only the package in that case.
Yeah, no, I get it. Okay, so further conversation, I think. We can talk later.
Sure, absolutely, yeah.
All right.
Hey, this is Sherman from Kando Bus. I got a
Hi.
few, hi, just a few comments.
Sure,
When I
yeah.
look at the SI performance, it looks to me there are a lot of
Yes, sir.
um, plenty of margin. You look at the S parameter and
Right,
also
right.
the I.
Mhm.
My estimation is the I looks to be like um, 160 millivolt I height, and
Mhm.
the I width is 45 picosecond. Just a very rough estimate,
Okay, you
which
have
is a
sharp
really
eyes.
big eye, you know,
Right, this is
right?
a very big eye, yeah.
Yeah. So my first comment is. It looks to me this design has the potential to go up to 32 gigabit per second. So do we have
Mm.
to complain, or we already actually taken that into consideration when we would design this demonstrate experiment package.
Yeah, and you are right. It has potential to go to 32 gig, given what we are seeing now here. But the dies themselves don't have a capability to operate beyond 20 gig, something
Mm,
in that range, right? It's a more
mm,
limitation of die rather than the channel.
Yeah, so yeah, maybe it might be possible if we replace the die with higher speed capability, we can test this package with a higher data
Exactly.
rates.
Exactly. Yeah.
Mhm, mhm.
Yeah. 32
My
gig will
second,
certainly be interesting. Yeah.
yeah. My second comment is PI is kind of tricky, especially for this kind of single-ended interfaces. So
Mm,
the noise is
mm.
much bigger than the differential
Right. Right.
interface. So my
Right.
way of dealing with this kind of problem is I put maybe more than required decaps on the package. And we probably needed
Mm-hmm.
to do a little bit of experiment to reduce the caps. First make sure the PI will be good enough to have
Mm,
the whole thing working. The
mm,
second is we might consider to reduce the unpackaged caps to the minimal provision. So
mm.
just to kind of reduce the cost.
Okay. Now you're suggesting
Yeah,
that we reduce the on-die decap and then increase the cap on the package. Is that what you're saying?
no, just kind of want to check or maybe just yeah ask
Okay.
have
No,
we
if I
put
understand you right.
more than maybe we should consider put but I know is the package is already taped out, so I assume the unpackaged decaps probably already have been configured more than sufficient. I
Correct,
guess.
correct, correct. The question is, how do you optimize the caps, right? But do we put more than what is required? Yeah, that is true. We have more than what is required,
Yeah.
right? And that because once we characterize, understand, this can be optimized,
Yes.
right?
Right.
Right
Yeah.
now we
Yeah.
have fear of unknown.
Yeah. That's yeah. So it looks like yeah, everything perfect. So we'll very much look forward to the test result validation report.
Sure, absolutely, absolutely.
Hmm.
And we'll also
Thanks.
have once the IEEE paper is published, we'll let you know that we'll provide a copy of that. And also, we're planning to do an OCP white paper as well on this power integrity.
Hmm. So the paper has already been published by IEEE.
Not yet.
Mm-hmm.
It will be soon, probably by November, December, I guess.
Mm-hmm. Yeah, actually, I did some search on IEEE, and I haven't seen a lot of papers
Mm.
regarding the bunch of wire or even UCIe. That's
Mhm.
something, yeah, kind of blank area which may need to be filled out in a very near future, I
Right,
guess.
right. You mean the power integrity, right? For the chiplet single-ended.
Both single integrity and power integrity, I
Okay,
guess.
okay, okay.
Yeah.
Excellent.
Neither of the areas, there are many papers, I guess. Just very few.
Hmm.
Yeah, one or two something.
Sure, yeah, that's certainly a very good input. Yeah, we'll have that
Yeah.
soon. And yeah, maybe your comments will also be helpful with the paper. Maybe I'll share that paper along with Ishan, and you can also
Yeah.
provide some review and provide inputs.
Yeah. Yeah. I think each member may also um, think about some ideas maybe worth putting into paper, and we may
Right,
collaborate on some of them. Yeah.
right. Yeah, thank you. Yeah.
Yeah. Sure.
Okay, I
Thanks.
think we are out of time. Are there any quick questions?
So I I want to
Hi.
know that whether it is possible to get some data of the uh, electrical performance presented today uh, before
You mean
the
the
paper was
you mean
published.
the signal and power integrity data?
Yeah, something like that. The data of different pairs of die-to-die communication with different reaches or different kind of
Sure,
die-to-die.
sure. We have an S parameter model available in Google Drive,
Oh,
and you can use that as a reference. And we also have layout available. And if you want to experiment with that, you're most welcome. Yeah.
thank you.
I'll have, may I know who is talking? I can point you to that files.